and welcome to Tech Talks, a series of podcasts related to science and technology, brought to you by Insight, the official student media body of IIT Bombay.
Today we have a very special host for you, Prashant Pawan, who is an ex-chief editor of Insight. Prashant is in conversation with Sonam Motwani, who will be introducing herself shortly.
Hi, I am Sonam Motwani and I am the founder of Karkhana.io. We simplify manufacturing so that new products go from prototyping to production in a matter of a few days.
Hey Sonam, thanks for joining. It's great to have you here. Just to go back a little bit about how all this started, you did your undergrad at IITB in aerospace, is that correct?
Yeah, Prashant. So I completed my bachelor's in aerospace engineering from IIT Bombay in 2013.
Nice. And how did you get from there to what you're doing today? Like where did the interest in manufacturing come from?
Sure. So when I made the choice of going for aerospace, the main reason was that it sounded pretty cool. I didn't really know much about what exactly I was going to learn in this particular stream. So after I started at IIT, like most enthusiastic first year students, I tried my hand on a bunch of things, starting from arts, sports, to getting involved in tech. And I think tech was what struck the chord most with me. So I got into robotics in first year. From there, I moved on to building race cars for this competition called Formula Student. And I think that is what stayed for most of the part, or rather, I'd say all the time I spent building race cars with my team was what defined my time at IIT.
That sounds.
It
Oh, go ahead.
it was also a lot about the camaraderie that it brought along, working together as a team towards a common goal. So that's what got me started here. It was my first encounter with manufacturing. And then I started my career with P&G, and where I was solving multiple engineering problems across different business units. So that was where I saw the underlying challenges in manufacturing industry in India. And what I figured was that it was extremely challenging to procure a custom part or product, or even finding the right manufacturing partner was an extremely tedious activity. There was no easy way to figure out which manufacturing process to go for, where to manufacture, what a fair price would be to pay for a custom part. So, all in all, I found manufacturing as a highly unorganized industry, and that was what I wanted to change.
Got it. And I think you're talking a little bit about how the industry exists, in India at that time at least. Was it very different outside? Like, did you have insights into how it worked across the world as well?
So actually, that was the experience that the job at P&G gave me. So when I was working as a part of engineering team across different business units at P&G, there we were working with a lot of suppliers who were in China, in Eastern Europe, and there what we saw that there was quite a lot of difference in the professionalism between the suppliers, the speed of coordination. But when we were trying to localize some of that business to India, the experience was a little contrasting in the sense that there was the lead time for manufacturing was much longer. The speed of response that we got from the suppliers was much longer. And even to figure out that out of the group of suppliers that we were targeting to work with, which one would be the right choice was something that took us a lot of time here in India. So those were some of the differences that we felt. and like naturally there is not much data out there, or I would say organized data out there on the internet that one could gather and make such decisions here in the country.
Yeah, that's. I mean, that totally makes sense what you're saying. And would you say like things are starting to change a little bit now, or like is it, I mean, I'm sure there's still a ways to go, but how are things looking since you started?
I think one of the major factors that is bringing about some change and would bring about larger changes in the years to come is the general push towards digitization. We are seeing most of the industries going online, most of the industries seeing a lot of adoption of smart devices. Like now, everyone here seems to be using a smartphone and being pretty confident with that. So same goes for manufacturing as well. Be it a machine operator in a small machine shop to the factory owner, everyone is pretty well versed with using Android phones, and I think there is a lot that could be done on that front. That if we could create such pieces of technology which could be adopted through such smart devices, then there a lot can happen that would transform the way manufacturing works today and do the phase change from being a very slow paced and traditional industry to a fast moving and modernized one. So that's where I think a lot of effort is being made over the past 3 to 4 years, and a lot of effort that we would see in the next few years to come as well.
That's very interesting. It's not something you would think about, but it totally makes sense that because now people are using smart devices a lot more just in their personal life for communication or entertainment. That ability to work with those devices obviously translates into the workplace as well, no matter what the industry. The fact that these people would now be more comfortable, like working with all kinds of digitized devices, totally makes sense. It's just not something that would strike you as obvious, right, when you think about it.
Yeah.
Very
True.
cool. And I mean, in fact, on the other side of that discussion, manufacturing is not something a lot of common people understand. Like I don't like. Obviously, we know that there's a lot that goes into it. We know we benefit from using a lot of devices made through cutting edge manufacturing processes. But to an extent, we don't know what's going on under the hood. We take it for granted, right? And when you and I were talking about doing this discussion, you brought up a lot of those interesting nuances. I was hoping you could talk a little bit about that. Like if we consider something like a safety razor, and just this looks like a simple object, right? But what all goes into making one?
So actually, grooming or shaving has been an important cultural practice for humans since primitive times. Nonetheless, like even till early 1900s, most men used to still shave at the barber. And that's when slowly the adoption of razors came into a household practice. And now, what we see very commonly around us is the modern version of safety razors. What seems very commonplace actually is a novel piece of engineering and manufacturing. So, I'd like to deep dive a little on what goes behind manufacturing one. So let me first get started with the blades of the razors itself. The blades that we see on the razors, all of them, or rather most of them, are of the same size and of very very accurate dimensions. So in fact, the material that is used to make the blades is also has a very very particular composition. So it contains chromium, which essentially makes the steel difficult to rust and prevents any type of corrosion. Also, it has some percentage of carbon that hardens the blade. So also, if you see the thickness of the material for the blade, it's about 0.1 mm. So it's more like a tape-like material that that is cut into a particular shape. So how the stainless steel that is used gets to become so hard at the same time can be bent, I'd want to discuss a little bit about that.
Yeah, of
So
course.
the steel that is utilized here is first hardened by heating it in an electric furnace to temperatures as high as 1000 degrees Celsius, and then it is got made to rapidly cool at a very low temperature of minus 80 degrees Celsius by quenching it into water. This makes the steel very, very hard, but at the same time, it's quite brittle at this stage. So next, what is done is the process called tempering, where the material is then again hardened to a temperature between 250 to 400 degrees Celsius, and then slowly cooled at atmospheric temperature. This second heating cycle essentially gives elasticity to the stainless steel that is used, and the material now ends up becoming hard to break. At the same time, it maintains the elasticity that makes the material easy to bend as well, but regain its shape after you release it.
Okay, very cool. And obviously, one of the important parts of the blade is the edge that cuts, right? And I would imagine a lot goes into making sure that edge is, it has the properties it needs and so on.
Yeah, Prashant. So, in fact, the process of forming the edge of the blade is also called edging. So, the way it goes is that it's also a multi-stage process. The edge of this cut piece of stainless steel is then made to grind against a coarse whetstone first, and then you move from the coarse one to the next finer whetstone, and finally go for grinding the tip of the blade with an even finer whetstone. So it's essentially start from coarse, go to second stage finer whetstone, and then to the finest whetstone to get final sharpness on the edge of the blade. After this three-step process, then the burrs that come on the edge are removed through the polishing process. After the polishing process, there is some sort of coating that is applied to the blade, which essentially makes it even more smooth across the skin. Also provides additional rust protection to the steel. So this, all in all, increases the durability of the razors.
Got it. And this is done for like millions upon millions of blades too, right?
Yeah, in fact, good you asked this, because the speeds at which these blades are produced go up to 100 to 1200 units in a minute. So
Wow.
that's like really, really fast. In fact, it gets me thinking that since there are 1000 blades being produced in a minute, there must be around that many razors that are getting utilized in a minute. So it's just a boggling fact.
Yeah. You don't realize the scale of it. Like it makes
Yeah.
sense when you think about it, but totally. There's going to be like quality control to be maintained as well, right?
Actually, there's a lot that goes behind inspecting each and every piece of blade. There's an interesting fact. So if you look at the blade, you'd see that most of the surface of the blade reflects light and shines, whereas the cutting edge is something that appears black under light. That's the inspection process that is used to make sure that every blade that is produced and passed for quality meets this criteria, that the edge of the blade does not reflect any light and is completely black. If it ends up reflecting any light, means that it is not sharp enough and gets rejected as a defective product.
Cool. And all this is just in the blade.
Yeah.
There's still the rest of the handle and whatnot for something you would think is a simple device.
Yeah, so there are actually plastic portions in the cartridge also. So you'd see there is plastic on the top, there is plastic at the bottom, and then there's something that's holding two blades together in the cartridge. Those are tiny plastic pieces that essentially form the cartridge and the assembly part of the blades. In fact, a lot of blades today, or rather the cartridges today, have a strip of a special type of resin, which when exposed to water becomes like a slippery substance which provides ease of shaving. So it's essentially a resin that reacts with water and forms a soft layer so that there are no cuts while shaving.
Oh wow, okay. Is that something that can you can see with the naked eye? I'm trying to recall if I've noticed it.
You must have seen a blue line on the cartridge, and that's something that also get used away with every shave.
Right,
So and it forms a soapy layer when you shave.
right. Okay, it's the same thing. I didn't realize
Yeah.
that it also aids in like a smoother, feel of the blade. Like I always thought that was just an indicator. So that's good to know. Uh, Very cool. And that's kind of what goes into the cartridge, is what you're saying.
Yeah, yeah. And then there is the handle part. So even on the handle, a lot of good quality razors would have two different types of plastics come together. So one is that provides the rigidity to the handle, and then there is softer rubber-like plastic that is coated over the hard plastic and provides a good grip to the razor. So here also there is a complex injection molding process where two different types of plastics go into the same mold, and after one plastic is molded, the mold rotates, and then another softer plastic gets into the mold and covers up on the hard plastic and forming a soft rubbery layer.
Got it. And so I guess the idea there is the inner plastic is to make sure it's sturdy enough, right? And the rubbery layer is more like for usage, like that's the idea there in making it.
Yeah.
Yeah.
Yeah, so it makes the grip of the handle better
Yep.
and easy to use for the razor overall.
And I think one thing that I mentioned to you even when we were talking about this earlier was how like there's the metal components of the razor, right? And then there's all the plastic components coming together as well. And that I'd imagine is something pretty common, right? In most things we use, where there's metal components that do their job, and then there's the plastic that is serving a different purpose. And you were mentioning how there are many cases where the metal really is plastic.
Yeah.
And yeah, and I think we said even things like phones and laptops have some such surfaces. Did I understand that right?
Yeah. Yeah, so in fact, a lot of phones that we see around us, it's very hard to say whether the body is made up of plastic or is it metal. Like only when you've left it on the table for some time and you touch the surface and you find the surface cold, that gives you an impression of the body being metal, but otherwise by the appearance of it, it's pretty hard to conclude whether it's plastic or metal, because the kind of advances that we've made in terms of how plastics could be made to look like metals through different plating technologies where you deposit a layer of other materials on plastics which give it the same shine and luster and make it look like a metal.
And is that makes sense? And is that done like for an aesthetic reason or like what?
So there are multiple applications to it. One, if you have to make something out of metal, uh, it's much more complex and expensive. Whereas if a very complex shape has to be achieved on a plastic, that's a cheap. There are like a lot of cheaper ways to do that, as well as that's a simpler thing from manufacturing perspective. Getting different shapes and contours in plastics is more economic as well as a simpler process. So that's why it makes plastics more favorable on a lot of devices around us. And secondly, plastics are much lighter than metals. So that's where we see a lot of automotive components are made of plastic, but no one, or rather, when you see plastics on luxury products, it can be quite a bummer. So to still conceal the appearance of plastics and to make them look rich like metal, the modern plating processes come handy.
Ultimately, the reason is people like seeing a metal-like finish. It sounds like, right? Like that's the desired look of the product that customers want. And but then the challenge with that you're saying is it's not as cost effective as plastic metal manufacture, and it may not be as amenable to like molding it into different shapes or achieving tight corners, for lack of a better phrase. Um,
Yeah.
and so that's why plastic is used, but it's made to look like metal. That's very interesting. Like how a manufacturing innovation had to be made, you know, because of what is ultimately a customer preference, right? Like it's not necessarily based on how the product performs. It's more of an
Yeah.
aesthetic. Very nice.
Yes, especially in products that we interact with on a daily and, in fact, like hourly basis. We prefer those products to look good to the eye as well. So, yeah, I think in most of the devices that we use around us, it's becoming harder to say what's plastic, what's metal.
You mentioned cost effective, and I was like just wondering, in a manufacture of a lot of these things, obviously cost plays a big role, and it's something that gets transferred to the end customer as well. Like the costlier it is to manufacture, it's reasonable to assume that the price of the product will be higher as well. And you mentioned how plastic is slightly more cost effective than, say, metal. You do see a range of products, like a range of prices, even with like plastic made products, right? Like you have things that cost like maybe $1 or a rupee, all the way to like thousands of dollars and rupees. And when we were talking about this earlier, but I think one interesting example you brought up is like the tea lights that we use in festivals like Diwali, like the lamps that you light up. And you were
Yeah.
mentioning how they're extremely cheap, like just a rupee, under a rupee, I think is what you said.
Yeah, yeah.
Like
So,
how is
in
that?
fact,
Yeah.
yeah, so actually, I was quite intrigued knowing the price of a tea light when I bought some during Diwali. And that made me do some number crunching behind how that product could be sold. And when I say sold, like that's the retail cost, not the wholesale cost of like 1 to 2 rupees. So if you look at the tea light, it contains of an aluminum container. Then it has the wax coin inside it, and it has the wick. After that, there is like a bundle of 15 to 20 of those packaged together, and there would be some sort of sticker or label put on it. And then a lot of these bundles would then be packaged in cartons, sent to different warehouses. From those warehouses, probably they'd go to different distributors, to retail shops, and even to the roadside vendor. And from there, you could buy a packet where the cost of one tea light would be in the range of 1 to 2 rupees. So what I did was I tried to figure out how that could be possible. So if you look at the cost of aluminum, I'm assuming here that it's bought in bulk when you have to get into bulk manufacturing of tea lights.
Right.
So aluminum costs somewhere around 150 rupees a kg. And then I did some math to figure how much aluminum would approximately go into making the case for one tea light. So that came to around a gram,
Okay.
which then roughly costs around 15 paise. Now, coming to wax, the common wax that's used in candles costs again in bulk around 60 rupees a kg. And in one candle, the amount that would go would be between 5 to 6 grams. So I approximated it to come to around 35 to 36 paise. Then there would be the cost of the wick, which I would assume would be like 1 to 2 paise, looking at aluminum costing 15 paise. And in the scheme of things, then I'd assume that packaging and shipping would be another 10 paise contribution to one tea light. So all in all, that comes to around 60 paise. So still there is room for another 40 to 50 paise to spend on logistics, etc., and still make margins on this product that the consumer buys at 1 to 2 rupees.
Got it. So this was all really great to understand. And plastics obviously are something that are now an indispensable part of everything we use, right? But you do also read and hear about the environmental or the sustainability implications of using plastics, right? Whether it comes to biodegradability or just being more responsible about how we use plastics.
Yeah, actually, there are certain type of plastics which have been banned for usage in
Right.
certain geographies, where there are other plastics which pass that criteria and continue to be used. I think as consumers, we really need to be more cognizant about what goes behind the products that we used, what kind of impact on the environment different materials create, and I think that's one of the areas of change that I think would be interesting to have, or rather important to have in the years to come. That if we could know what sort of impact the products that we purchase on a daily basis, the products that we use on a daily basis, create on the environment, what goes behind manufacturing those parts and products, and then we could actually make better decisions in our purchases. But I think that's something that the industry as such would not push towards.
So it's something that you're saying that regulators and governments will
Yeah,
have
yeah,
to.
it's the regulators, the governments could bring about a change in making the consumer more aware about what goes behind the products they use.
Completely agree, and I don't think any technical discussion of manufacturing is complete without also discussing the sustainability and in addition to just the
Yeah,
manufacturing cost. Totally makes sense.
yeah.
Great. This was great, Sonam. Really nice chatting with you. There's a lot of things that we discussed. I think that like I said, you take for granted. You don't realize what goes into it. And then
Yeah.
when you start laying it out and saying, okay, here's how this is done and here's how this other thing is done, you realize how much there is to it and how many interesting problems there are to solve. All right.
I really enjoyed this discussion, Prashant. When you get into the depths of figuring out manufacturing, there are so many layers to peel that you can go on and on about it. Really glad we could have this.
Yeah, absolutely. And I hope you'll be up for having another discussion some other time on a different manufacturing related topic where we can go deep.
Yeah, I'd be super enthused to do that.
Awesome. Thanks, Sonam.
Thank you, Prashant.